Now that we've been using the Pythagorean theorem for a while, we're ready to do something called the converse of the Pythagorean theorem. So here's the I can statement for section 8.3. I can understand and use the converse of the Pythagorean theorem. Now we'll talk about what a converse of a theorem is in just a second, but we do want to just do a quick reminder. We want to talk about what a right triangle is. A right triangle is a triangle, so rather than write the word triangle, we're just going to use the symbol. So triangle with one right angle. One right angle. And when we say right angle, remember that's a 90-degree angle. If we've got an acute triangle, here's what it is. Again, it's a triangle with all three angles less than 90 degrees. All right, and then the last one is obtuse, and an obtuse triangle has exactly one angle more than 90 degrees. So with a right triangle, we've got one right angle, one 90-degree angle. With an acute triangle, all three of the angles are less than 90 degrees. And with an obtuse triangle, it's got exactly one of them that's more than 90 degrees. So a right triangle would look something like this, okay? An acute triangle might look something like this, where all of them are less than 90 degrees. And then an obtuse triangle would look something like this, okay, where we've got this big angle right here that's more than 90 degrees. Okay, next question. What is the Pythagorean theorem? State the answer in words and give the formula. So again, I'd much rather have you remember this. It's leg squared plus leg squared equals hypotenuse squared. Then remembering this, a squared plus b squared equals c squared. Now they're both important, but the cool thing about that statement, leg squared plus leg squared equals hypotenuse squared, is it really contains all of the information that you'd need. If we've got a hypotenuse, that name only applies to right triangles, so we know we'd have a right triangle, and we're taking the two short legs, leg squared plus leg squared equals hypotenuse squared. So it says, on what type of triangle does the Pythagorean theorem apply? It only applies to right triangles. That's it. So please don't try and use it on anything else. Okay, now the Pythagorean theorem says this: if we have a right triangle, then the sum of the squares of the two legs is equal to the square of the hypotenuse. The converse of this, so go ahead and write the word converse, the converse of this is also true. So this is an if-then statement. The Pythagorean theorem says if we have a right triangle, then the sum of the squares of the two legs equals the square of the hypotenuse. So if we've got a right triangle, then leg squared plus leg squared equals hypotenuse squared. Well, the converse of this is also a true statement. So let's talk about what a converse is. So the converse of an if-then statement, okay, so this is an if-then statement. So it's an if-then statement where the if and the then parts have been switched. So I've got an example right here. Here's the if-then statement. If you got above 92%, then you got an A. So if the cutoff for to get into the A category is 92%, as long as you got higher than that, you got an A. So here is the if part. Okay, the if is you got above 92%. The then part is you got an A. So if we were to switch those around, so this is the converse of that statement. If you got an A, then you got, so we put the then part right here, that means we put the if part over here, then you got above 92%. Okay? If you got above 92%, then you got an A. So if you got an A, then you got above 92%. Now, switching these around, let's think about this. If you got above 92%, then you got an A. Yeah, that's true. If you got an A, then you got above 92%. Okay, that happens to be true regardless of which direction. So the converse of an if-then statement is not always true. Okay, it does depend on the statement. And we could come up with an example of an if-then statement where the converse is not true. So for example, we could change this to if you got a 95%, then you got an A. The converse of that would be if you got an A, then you got 95%. Well, that wouldn't be true because there are people that maybe they got a 99 or maybe they got a 93 or something like that. They could still get an A, but they didn't get that exact percent. So it does depend on the statement. So let's take a look at the Pythagorean theorem and how we'd write the converse of that. So if you have a right triangle, then a squared plus b squared equals c squared. Then leg squared plus leg squared equals hypotenuse squared. The converse of that would be switching these things around. If a squared plus b squared equals c squared, then you have a right triangle. So that would be the converse. Now this is a true statement. So if you've got a right triangle, then leg squared plus leg squared equals hypotenuse squared. If leg squared plus leg squared equals hypotenuse squared, then you've got a right triangle. So this is the Pythagorean theorem, and this is the converse of the Pythagorean theorem. Now you'll notice something about these diagrams right here. You'll notice that there is no right angle in here. Now, in order to figure out whether or not we have a right triangle, we've got to match this up in the right way. So remember, these two are legs, and this is the hypotenuse, and the hypotenuse is always going to be the longest one. So here it says, state whether each of the following is a right triangle. We don't know whether it's a right triangle. That's what we're trying to figure out. So let's take a look at this right here. We've got a 9, a 12, and a 15. If this was a right triangle, then this would have to be the longest. Okay, this is the potential hypotenuse. So I'm going to write HYP question mark, and I'm going to write leg here, and I'm going to write leg here. We could use the word leg for any triangle. It doesn't necessarily have to be a right triangle, but if we use the word hypotenuse, it's got to be a right triangle. So the question here is this actually true? So let's write this down. This would be leg squared plus leg squared, and I'm going to put an equal sign with a question mark above it. Does that equal 15 squared? So let's check and see. This is 81, this is 144, and over here I'm going to put a question mark still. This is 225. So grab your calculator if you need to. I think this is going to work out pretty well. 81 plus 144. We get 225. 225 equals 225. So here's what this means. This means that the leg squared plus the leg squared equaled what we thought might be the hypotenuse. So the answer on this one is yes, this is a right triangle. Okay, because when we square these two legs, it does equal exactly what the hypotenuse is. Okay, so let's take a look at this one. Now, the way they've got this set up, this is 9. It's definitely smaller than 11. This is the square root of 115. We might want to type that into the calculator and see if it's smaller than 11. They might. I mean, I suppose they could try and trick us. But if you stop and think about this, if I squared this, this would be 121 when I square it. That would be the square root of 121. So this is smaller. These two are the small ones. So again, I'm going to write HYP question mark, and we're going to do leg squared. This looks really awful, but remember it's not. Leg squared plus leg squared equals hypotenuse squared. So I'm going to put the equal sign and a question mark right there. 11 squared. So let's see what we've got here. This is 81. Let's see if I square a square root. These undo each other, so this is 115, and then over here we get 121. Whoops, 121. I mixed those up there, 121. So let's add these together and see what we've got. So this would be 81 plus 115, and we end up with 196. So this is 196 and 121. And if we got a question mark right here, now I can say, you know what, these are not equal. Okay, so we would say not a right triangle. Not a right triangle. Okay, let's look up this last one. This one looks pretty awful. I'm going to zoom in on this just a little bit. So let's take a look here. Let's see. This is 10. That's definitely smaller than 16. I am not sure about this right here. So let's grab a calculator and let's check and make sure that that one's the smallest one. So here's what we've got. 2 and then radical 39. Now I think we're probably okay here. I'm going to hop out there. So this is 12 point something. So this is 10, this is 12 point something, and that's 16. So I am going to write HYP question mark, and then we're going to do leg squared plus leg squared. Now I'm going to write it like this. Now this has an asterisk on it, and this is why. We haven't seen one like this before. Okay, and I need to put a question mark and 16 squared. So leg squared plus leg squared equals hypotenuse squared. So 10 squared is a piece of cake. That's just going to be 100. Okay, now I want you to stop and think about what would happen here. This exponent is going to apply to whatever it's over, and we're going to be practicing this type of thing in a couple of units. So what this means is we have 2 radical 39 times 2 radical 39. What it means is we have two 2's, which would be a 4, and we have a radical 39 times a radical 39, or radical 39 squared. So remember what this is going to do to the radical. It's just going to make that a 39, and we have the 2 squared right there. And then let's see, we get 256 if you remember that from your perfect squares. So let's check on our calculator. Let's hope this works out right here. 4 times 39 equals, that's 156. So 156, question mark right there, 256, and those two things are equal. So yes, this is a right triangle, okay? Because 256 would equal 256. Okay, now just as a double check, I want to show you what happens if we did this. Let's do a set of parentheses. Let's do 2. Let's do the square root of 39. Whoops, I need to get back here and delete that. Hop outside. Then put that, and then square that. So you'll notice I've got the 2 radical 39 squared, just like I had up here, and watch, that's going to give us 156. Okay, so we're in good shape right there. Now, the next question is this. What if a squared plus b squared doesn't equal c squared? So what if we run into this right here, where they're not equal to each other? Is there anything we can say about the type of triangle that we have? Well, let's see. The legs were way too big. When we squared those 196, they're way bigger than the 121, so they're way too big for the hypotenuse. Well, it turns out we can use a little bit of logic to determine what type of triangle we have. So here's the idea. To determine if we have a right, acute, or obtuse triangle, compute a squared plus b squared and c squared, and then check to see if c squared, so if the hypotenuse squared is exactly the same as the two legs squared and added together, then we have a right triangle. Okay, so it's exactly the right size. That's what happened here. When we squared a squared and b squared, added those together, we got 225. It's exactly the same as c squared. It's exactly the right size. If c squared is smaller than a squared plus b squared, that's what we had right here. C squared was smaller, then what happens is we've kind of got a right triangle where we had to shrink things in. If this was the hypotenuse, it got smaller, so what it did is it made this a smaller angle. So we have an acute triangle. And if c squared is bigger than a squared plus b squared, then we have an obtuse triangle. And whoops, obtuse. And if we had an obtuse triangle, this is what happens here. So we've got our legs, and this ends up being too big. Okay, it's too big. Get rid of that. Too big. So if this ends up being too big for the two legs, then what it does is it stretches this out. It makes it bigger than a right triangle. Okay. Now remember, the hypotenuse is always the longest side. Okay, and when we say hypotenuse, what we mean is the potential hypotenuse. Okay, because if it's a right angle, it's going to be across from the 90-degree angle. That would be the biggest angle. So we've got to make sure that we use that potential hypotenuse as the longest side. Okay, and again, we'll say across from biggest angle. Okay, so the instructions on this part say, state whether each of the following is a right, acute, or obtuse triangle. So of these three, this has got to be the C. The other two really don't matter at all. So we're going to do 12 squared plus 9 squared, and we're going to compare it to 17 squared. So this is 144 plus 81. So let's check that. So 144 plus 81 equals 225. So this is 225. And then 17 squared, I'm hoping you remember what that is. 289. 289. Okay. This is the hypotenuse. So the hypotenuse is too big. If it's too big, this is obtuse. Whoops, obtuse. Okay. So just compare that hypotenuse to the sum of the square of the legs. And if it's too big, it's going to be obtuse. If it's just right, then it's right. And if it's too small, then it's acute. It's kind of a quick way to remember it. Okay, notice the sizes that we have here. So let's take 9.6 squared plus 18 squared, and let's compare that to 20.1 squared. And let me show you a little trick. Let's just type this whole thing into the calculator. This is not something that I want to do in pieces. So let's do 9.6 squared plus 18 squared. We get 416.16. And let's do 20.1 squared. 404. Okay, so here's what we've got. This is 416.16. And the other one was 404.01. 404.01, right? I think we had that right. Yep. Okay. So compare these. This is the hypotenuse. Okay. This is our hypotenuse. This is our hypotenuse. Okay. And compare it here. It's too small. It's not big enough to equal that. So it's too small. So this would be acute. Okay. Now you'll notice in this problem C, they give us an A, B, and a C. So let's just go through and see what we've got here. So this would be 6 squared plus 2 radical 55 squared. And again, notice we've got that 2 and the radical 55 underneath there. And then we've got 17 squared. So here is our potential hypotenuse. This is 289. Again, we've done that one before. This is 36. And then again, stop and think about this. This is going to be 2 squared, so that's going to be a 4. And what does squaring a square root do? These undo each other, so this is going to be 55. So we've got 36 plus 4 times 55. Whoops. Come back here and hit times 55. Hit enter and see what we get. We get 256. Interesting. 256. And we've got 289. Okay, that means this is the hypotenuse and it's too big. So too big, that means obtuse. Okay, that's going to be obtuse. Now just to double check, always makes me a little uncomfortable when we've got all this floating around here. So I'm going to clear this off and we're going to do 6 squared. We're going to make the calculator do all of this for us. Plus, and then in parentheses, 2, and then I'll do the square root of 55. Hop outside there, close the set of parentheses, and square that. And let's see what we end up with. 256, and that's 289. So it is too small. So that, or sorry, too big. So that would be obtuse. Yep, definitely too big here. Too big. And make it so you can see that 89 there, and we'll circle the obtuse. Okay, let's look through here. Let's see what we've got. We've got an asterisk by this, so we probably ought to be a little bit careful. That is a leg, that is a leg, and that's the hypotenuse. So let's do 4.8 squared, 28.6 squared, and let's check 29 squared. So let's throw this in the calculator. That's kind of a mess there. We'll square that, plus 28.6, we'll square that, and we end up with 841. So 841 here, and let's check 29. So 29, and we'll square that, hit enter. 841. Okay, just right, just the right size. So this is a right triangle. So we can not only tell whether or not we've got a right triangle, we can actually use the converse of the Pythagorean theorem to classify it as, is that old right angle, is it too big? Did it become obtuse? Or is it too small? Did it become acute? Okay, here's a last problem right here. It's a thought question. Can you make a triangle out of sides that are 4, 5, and 10? 4, 5, and 10. Now I don't know that they give you any of these on today's assignment, but this is something that you learned in 7th grade. This is called the Triangle Inequality. See if you remember this. The two legs have to add up to be at least as big as the longest leg. So if I take the two of these and add them up, I get 9. That has to be bigger than 10. If it's not, no triangle. There's no triangle there. And you might remember what happened here. If this side is 10 and we kind of put this on a hinge and this on a hinge, and this is 5 and this is 4, if we tried to swing these together to make them touch, these would kind of swing down here and there would be one unit right in between there. They wouldn't even come close to touching. In fact, if we did one like this, where this is 5 and this is 5 and this is 10, they would swing down here and they would just barely touch. Okay, We have to make this one like 5.1 or something like that before we'd have a little bit of a sliver of a triangle, something like that. Okay, so that's called the triangle inequality. What we practiced today is called the converse of the Pythagorean theorem, and it allows us to classify triangles as right, acute, or obtuse. Obtuse based on the size of those that potential hypotenuse, if you want to think of it that way. All right, good luck on the assignment.